Okay, so if we're asked to differentiate the function on the left, okay, we can do this one pretty easily. So we can just start with something like this. And then we're going to take the index, so take the power and put it at the front, and then we can subtract 1 from that. Okay, so that's just going to give us 2x. Okay, so the derivative is 2x, and we just disregard the 1 there. Okay, so that's nice and easy. The second one you can see is a little bit more complicated. We can start with the same sort of thing. Okay, so we can start finding the derivative like this, and it's going to equal. And if we take the 2 and put it at the front, it's going to be 2x. But then we've got this bracket here, and that's a little bit different. And we've also got this other power here, and you can see there's just a few more things going on. Okay, so we have to do something else with this second function, and this is where we're going to have to use the chain rule. Okay. And I'll show you what the chain rule looks like. So it looks something like this, all right? So the derivative is going to equal, and it's going to be the derivative of u times the derivative of v, okay? And this is probably not making a whole lot of sense if you've never done this before, but I'll explain exactly what u and v are in just a second. Okay, so first of all, before we start doing it, let's have a look at what's happening here. Okay, so it's almost like we've got two functions here. Okay, so we've got x squared plus 1, and that's just our original function that we looked at in the first question. Okay, so x squared plus 1, but then we've almost got that within another function. Okay, so we've got x squared plus 1 within something to the power of 6. Okay, so it's almost like there's two functions going on here. So what we're going to do to start with is we can go let u equal, and here's our first letter. Okay, so u, let u equal, and u is going to equal the inner function. Okay, so it's the function within the other function. So it's going to be x squared plus 1, and that's just that one there. Then we can also let v, and there's the second letter. V is going to equal the first function, okay, within the second one. So it's going to be u to the power of 6. Okay, so hopefully this isn't too confusing. But I've taken that function, x squared plus 1, which I know is equal to u, okay, because I designated that. That's to the power of 6. Okay, so it's u to the power of 6. Okay, so here are my two letters, u and v. Now what I do is I differentiate each of them. Okay, so I just differentiate this first one, and it's going to be 2x, and we found that in the first question. Okay, so that's what we did in that first question there. And then I differentiate the second one as well, and I differentiate this one with respect to u. Okay, so it's going to be 6u and to the power of 5. Okay, and you can see now I've got the derivative of u and the derivative of v. Okay, so they're the two things that I need for the chain rule. So now what I can do is I can put this together. Okay, so the derivative is going to equal, and it's going to be the derivative of u times the derivative of v. Okay, so it's just going to be 2x times 6u to the power of 5. So I'm just going to do that. So it's going to be 2 times 6, which is going to be 12. Okay, and then we've got that x there, so I need to keep that. And then we've got u to the power of 5. Okay, and that's pretty close. Okay, we're pretty much there. We just need to do one thing. Okay, so you might see that we've got an x and a u in our answer. That's not ideal because we shouldn't really, have this u because we introduced that. So what we should do is just change that so that it looks something like this. Okay, so I know that u is equal to x squared plus 1. So what I can do is just replace u with x squared plus 1. Okay, so that's going to look something like this. Okay, and then it's u to the power of 5. So I just go like that. And that's it. Okay, so that's our answer. Okay, so here's two more examples, and feel free to pause the video and have a go at these ones yourself. They're a little bit harder than the first two that I just went, well, the first one that I just went through, but have a go yourself. And once you're ready, you can have a look at how I go through it. Okay, so first one, first of all, I'm going to let u equal, and it's going to be the inner function there. So it's going to be 3x plus 4. Okay, so that's just the inner function. And then v is going to equal, and it's going to be 7u to the power of 5. Okay, and yeah, so it's just a 7, and then I know that u is 3x plus 4, and then to the power of 5. Okay, and then I'm going to do this. All right, so I'm going to go like this. It's going to be 3. Okay, so the derivative of u is just 3. And then I find the derivative of v, and that's just going to equal 35, and then u to the power of 4. Okay, so now I just use my chain rule, and I might just quickly rewrite it down here. So it's going to look something like this. Okay, so the chain rule is equal to the derivative of u times the derivative of v. And something I meant to mention earlier and I forgot, you might also see something like this for the chain rule. Okay, so this is the chain rule that I like to use. That just makes sense to me. But you might also see this. Okay, so you might see something like dy du times du times dx. Okay, so if you see that, don't worry, don't be confused. It's the same thing. Okay, it's exactly the same thing. It's just using different notation, but don't let that confuse you. Okay. All right, so here we are. So now what we can do is just put together our two functions, our two derivatives. So we've got the derivative of f of x is going to equal, and it's going to be u, the derivative of u, times the derivative of v. Okay, so just using the chain rule down there. And that's going to be 3 times 35, which is 105. And then it's u to the power of 4. Okay, so that's pretty close, but we just need to now replace the u with what we know u is equal to. So it's just going to be 105 3x plus 4, okay? And all of that to the power of 4, okay? And that's it. So that's the final answer for C there. Okay, so this last one is, yeah, again, it's a little bit different, but if you just step through it like we have with the previous two examples, you should be fine with it. So let's first of all rewrite this, okay? So whenever I have a square root and I'm trying to differentiate, I always rewrite it. It just makes it a little bit easier and makes it less likely that you'll make simple mistakes. So I always do this. I always rewrite it as to the power of a half, okay? So we know that if we put something to the power of a half, it's the same thing as taking the square root, okay? So just rewriting it like that. So now what I can do is I can let u equal, and it's going to equal my inner function. So it's going to be 25 minus x squared, like that. And then v is going to equal, it's going to be u to the power of a half, okay? And I'm going to run over him here, but I'll see if I can do it. Okay, so I'll put that there so it's maybe a little bit clearer. So the derivative of u is going to be minus 2x. I think that's right, minus 2x, yeah. And then the derivative of v is going to equal, and it's going to be a half, and then u to the power of negative a half. Okay, so remember what I've just done here is taken that index and put it at the front, and then I have to subtract 1 from that index. So it's going to be a half minus 1, which is going to go down to minus a half, okay? So we've got u and v, the derivatives of u and v. So now what we can do is put them together, okay? So it's going to be something like this. So it'll be minus 2x times a half times, 1/2 u to the power of negative a half. Okay, so I'm going to start by going negative 2 times a half, which is going to be minus 1. Okay, and I won't write the 1 there, but we've got the x, so it's going to be minus x, okay? And then u to the power of negative a half. Okay, so that's, yeah, u to the power of negative a half just there. Now what I can do is replace that u, okay? So we're going to go minus x, and then we've got u is equal to 25 minus x squared, okay, just like that. And then we have minus a half. And this is pretty close, okay? We're pretty close to the end, but you should, it's better to avoid having a negative power like that. So what I'm going to do is rewrite it like this. So it'll be minus x, and then it's going to be 25 minus x squared to the power of a half, okay? So what I've just done there is dealt with that negative index. So I've just, whenever you have a negative index like that, you have to invert whatever you're dealing with. So in this case, I do 1 over 25 minus x squared. So that's going to give me that. And then final answer is going to be something like this. So it's going to be negative x over, and it's going to be the square root of 25 minus x squared. I think that's right. Yeah, that looks good. And that's it, okay? So you can see, even if we've got something like this with, square root and all of that, we can still use the chain rule and it'll still get us the correct answer.